Welcome to Session 3, Bar Graphs, Circle Graphs, Line Graphs, and Scales. The best graph depends on the question. Bar graphs compare categories, circle graphs divide one whole, and line graphs show change across ordered values such as time. But even the correct graph type can mislead when the axis is truncated, the intervals are unequal, or the unit multiplier is ignored. 10 real situations will train you to select a display, read its scale, calculate change, translate percentages into counts, and separate the numerical evidence from the visual impression. Example 1. A grocery store wants to compare sales of apples, bananas, oranges, and pears in 1 week. Choose the best display. Plan. Match separate categories with a graph designed for category comparison. Step 1. The fruit types are categorical values. Step 2. The goal is to compare one count or amount across categories. Step 3. A bar graph gives each category a separate bar. Step 4. Therefore, a bar graph is the best choice. Quick check. A histogram would be inappropriate because fruit types are not numerical intervals. This matters in real life because store managers use bar graphs to see which products need more shelf space. Example 2. A household budget assigns 35% to housing, 20% to food, 15% to transport, 10% to savings, and the rest to other costs. Find the other slice. Plan. A circle graph represents one whole, so subtract known parts from 100%. Step 1. Add the known shares. 35 plus 20 plus 15 plus 10 equals 80%. Step 2. The complete circle represents 100%. Step 3. Compute 100%. 80% equals 20%. Step 4. The other cost slice should be 20% of the circle. Quick check. The 5 slices now sum to 100%, confirming a complete budget. This matters in real life because families use part-whole charts to check whether spending matches financial priorities. Example 3. Monthly water use rises from 12 cubic meters in January to 18 in April. Find and interpret the change shown by a line graph. Plan. Subtract the earlier value from the later value and retain the unit and time direction. Step 1. The starting value is 12 cubic meters. Step 2. The later value is 18 cubic meters. Step 3. Compute 1812 equals 6 cubic meters. Step 4. Water use increased by 6 cubic meters from January to April. Quick check. Adding the 6 unit increase to 12 gives the April value of 18. This matters in real life because utilities use time series graphs to detect seasonal changes and possible leaks. Example 4. Graph's vertical grid lines represent 25 customers each. A bar reaches the 6th grid line. What value does it show? Plan. Multiply the number of intervals by the value represented by each interval. Step 1. Each grid interval represents 25 customers. Step 2. The bar spans 6 intervals from 0. Step 3. Compute 6 times 25 equals 150. Step 4. The bar represents 150 customers. Quick check. A bar at 6 intervals must be greater than a bar at 5 intervals, which would represent 125. This matters in real life because reading scale intervals correctly is essential in sales and attendance dashboards. Example 5. 2 class averages are 96 and 99, but a graph starts its vertical axis at 95. Explain why the picture may mislead. Plan. Compare the true numerical difference with the displayed distance above the truncated baseline. Step 1. The true difference is 99.96 equals 3 points. Step 2. Above the displayed baseline, 96 appears 1 unit high and 99 appears 4 units high. Step 3. That makes one bar look 4 times as tall even though the scores differ by only 3 points. Step 4. The graph exaggerates the visual effect by truncating the axis. Quick check. Report the actual 3-point difference before discussing the visual impression. This matters in real life because news and advertising graphics sometimes use truncated axes to make small changes look dramatic. Example 6. A line graph shows a company's revenue at 2.4, 2.8, and 3.1, but the axis is labeled millions of dollars. Interpret 3.1 correctly. Plan. Combine the plotted number with the unit multiplier printed on the axis. Step 1. The plotted value is 3.1. Step 2. The axis unit is millions of dollars. Step 3. Compute 3.1 times 1 million equals 3,100,000. Step 4. The revenue is $3.1 million or $3,100,000. Quick check. The decimal does not mean $3.10 because the axis supplies a $1 million scale. This matters in real life because financial reports often scale large values to thousands or millions for readability. Example 7. A circle graph shows that 27% of 800 survey respondents prefer online classes. Find the corresponding count. Plan. Translate the part-whole percentage into a decimal multiplier. Step 1. Convert 27% to 0.27. Step 2. Multiply 0.27 times 800 equals 216. Step 3. The slice represents 216 respondents. Step 4. State both the percent and count when explaining the graph. Quick check. Since 25% of 800 is 200, a 27% result slightly above 200 is reasonable. This matters in real life because education planners convert preference shares into expected enrollment counts. Example 8. A line graph rises from 250 website visits on Monday to 325 on Tuesday. Find the percent increase. Plan. Find the change, then divide by the original Monday value. Step 1. Compute the increase. 325, 250 equals 75 visits. Step 2. Use the original value as the denominator. 75 divided by 250 equals 0.30. Step 3. Convert 0.30 to 30%. Step 4. Website visits increased by 30% from Monday to Tuesday. Quick check. Increasing 250 by 30% adds 75 and produces 325. This matters in real life because digital teams use percent change to compare traffic growth across days with different starting levels. Example 9. A graph labels years 2022, 2023, and 2025 at equal horizontal spacing. What should a careful reader notice? Plan. Check whether equal visual spacing represents equal numerical or time intervals. Step 1. The gap from 2022 to 2023 is 1 year. Step 2. The gap from 2023 to 2025 is 2 years. Step 3. Equal spacing could make the rate of change look uniform when the time intervals differ. Step 4. The reader should account for the missing year or use proportional spacing. Quick check. Rates should be compared per year, not only by the slope drawn between unequally spaced dates. This matters in real life because business and climate trends can be distorted when time intervals are displayed inconsistently. Example 10. A community report needs to show both the exact monthly unemployment rates and their trend across a year. Which presentation is most useful? Plan. Choose a display for time trend and retain exact values in a supporting form. Step 1. Month is an order time variable. Step 2. A line graph clearly shows the direction and turning points over time. Step 3. A small table can list the exact percentage for each month. Step 4. Using both gives visual pattern and numerical precision. Quick check. The graph and table should use the same months, values, and units. This matters in real life because public reports often pair a chart with a table, so readers can see both the story and the exact evidence. Session 3 Recap. Use bars for separate categories, a circle for parts of one whole, and a line for change over ordered values. Read every axis unit and multiply by any printed scale such as thousands or millions. Check that intervals are equal and notice whether the vertical axis begins at 0. Calculate the actual difference before judging the picture. Quick check. Averages of 96 and 99 differ by 3 points. even if an axis beginning at 95 makes the second bar appear dramatically taller.